I'm Miss Vaughan. Today we're going to look at stationary points. Stationary points. It's a point where the gradient is 0. So then when you have a pen or a tangent, it looks like this, nice and flat. What's the definition? A point A, f of A, so your x and y, on a curve where y equals fx, so your function, is said to be a stationary point if f dash A equals 0. If you get rid of all of that and just look at that point, that would suffice us understanding it. Where f of A equals 0, that's a stationary point. Another way to say it is equivalently for y equals f of x, if dy dx equals 0 when x equals a, then a f of a is a stationary point. Here we have a graph, so we can follow the graph and we can see that at that point the gradient is 0. Then so we went from positive to 0, it's really hard doing it on the screen, to negative, less negative, 0 again, a little bit positive, really positive. So the stationary points are there and there. Where we can call this a f of a, we might call that one b f of b. So x and y values. Example 1. Find the stationary points for each of the following functions. So whenever you see the word stationary point, f dash a equals 0. That's what we're doing. So first of all, f of x, f dash x, sorry, is 3 times 2 is 6, and then minus 12, so 6x minus 12. And then we have to let it equals to 0. So now we have 6x minus 12 equals 0. Bring the 12 over the other side, so and 12 divided by 6 is 2, so x equals 2. Now stationary point means we have to find the y coordinate. To find the y coordinate, we sub x into which one? The original equation to find the y coordinate. So 3 times 2 squared minus 12 times 2 plus 5, which is 2 squared is 4 times 3 is 12. 12 times 2 is 24. So we have minus 7. So the stationary point is 2 minus 7. What about this one when we have a cubic? 4x cubed plus 6x squared minus 72x plus 48. So again, find the derivative, f dash x. So 3 times 4 is 12. 3 minus 1 is 2. 6 times 2 is 12. 2 minus 1 is 1. So 72x becomes 72. Don't forget the minus. So now when that whole thing equals to 0, we have something quite big. So what can you do? You can take out the 12. So let's do that. So we have x squared, 12x becomes x, minus 72 is minus 6 because 12 times minus 6 is minus 72. Now can you factorize that? What two numbers multiply to give you minus 6 and add to be 1? 3 times 2 is 6, so minus 2 because we wanted the middle to be positive. So now we have x minus 2 and x plus 3, so our x values are 2 and negative 3. Notice that this time we have 2 points. That's why the question is saying find a stationary point or points. So once we have the x values, what do? We find the y values. So f of 2, plug 2 in and we obtain minus 40. You can do that on your own slowly. And f of the other value is negative 3, so plug that in and we obtain 210. So to answer that question, let's put in coordinate form. So the 2 and the negative 40 and the negative 3 and the 210. Notice that the working out is getting pretty long, and this is why it's so important to keep it neat so you can find the values and not get mixed up. Example 3, find the stationary points for each of the following functions. So we are up to x to the power 4 plus 32x minus 20. So x to the power 4 is a quartic. So let that so you might have 0, 1, 2 or 3 answers. Let's have a look. So if differentiate that, we have bring the 4 down. 4 take away 1 is 3. And 32x just becomes 32. Now we let that equal to 0. So 32 becomes negative 32 when you bring it to the other side. Dividing by 4, we get negative 8. x cubed is -8, so cube root that, x is equal to -2. We only have one answer, thank goodness, less working out. So how do we find the y value? Plug it into the original equation. So we obtain -68. So our answer is -2 and -68 is the point where the stationary point is. Example 4. Find the stationary point for this function, minus x to the power 4 over 4 plus 8x squared minus 26. So let's differentiate it first. Bring the 4 down. 4 over 4 is just 1. So minus x to the power of 3, because 4 minus 1 is 3. Then 2 times 8 is 16, so we have 16x. Now let that equal to 0. So what can we do? We can take x out as a common factor, but don't lose it because x equals 0 is a solution. And then what can we do with x squared minus 16? We can use different two squares. Now x is equal to 0, 4, or minus 4. So this time we have 3 solutions, and so we have to find the y value 3 times. Painful, I know. So for the first one, use the original equation again. We have -26, that one's easy. For 4, plug that in, we obtain 38. And for minus 4, plug that in, we obtain also 38. So we have the 3 points, 0, minus 26, 4, 38, and minus 4, and 38. Try this out by hand so that you know that you can calculate these values, and also using the CADs. Example 5, the curve with equation y equals ax squared plus bx plus c has a stationary point at 1, 2, where x equals 0. The slope of the curve is 45 degrees. What does slope of the curve 45 degrees mean? It means tan 45 gives us the gradient, which is 1. So finding the point at the stationary point first at 1, 2. So let's do that. So the stationary point would mean to differentiate it. Bring the 2 down. We have 2ax, and that's just b. At 1, 2 means x is 1. The 2 is not the gradient, it's the y value. So that's why the gradient is 0, because it's a stationary point. Be careful with that. So now we have the equation as 2a plus b. Now what was the other piece of information? We have x is 0 at tan is 45, or in other words, the gradient is 1. Tan 45 equals 1. So now let's find define that. So f dash 0 equals 1. That's what that's saying. And we know f dash 0 would be just that with x is 0. So let's plug that in. 2a times 0 plus b equals 2b1. So now we have 1 equals b. So we can plug that in to find what a is. So 2a is equal to -1. -1 divided by 2, or in other words, -1/2. So a is -1/2 and b is 1. What is it asking for? Find a, b, and c. So we have a, we have b, and we know that there's 1, 2 there. So we can plug that in, 1 and 2 is our y, to find what c is. And c is equal to 1.5. So now we have a, b, and c. Thank you for watching. You might want to do that again a little bit slower, and I'll see you next time. Bye.